When we have a system of three equations and three variables, our go-to technique will almost always be elimination, because elimination is much easier to keep track of with larger systems. Substitution creates a lot of difficulties in the actual algebra. We're more likely to make actual algebra mistakes using substitution, and we'd like to avoid that. So here's a system where everything is already in standard form. We're actually going to typically meet equations in three variables in standard form already. In order to get started, I'm going to look at each of my variables, and I'm going to say, which one will be easiest to eliminate? Well, I'm going to rule out y, because y has all different coefficients here. Here I see there's an x term with coefficient 1, and there's also a z term with coefficient, well, -1, which is close. It's easy to multiply those by something to get the opposite of the coefficients in the other equations. So I'm going to choose one of those to start with. And I can choose to eliminate either x or z. I'm going to choose to eliminate z, simply because then I'll be down to an x and a y. Okay, so strategically, how am I going to do that? Well, equation 1 is going to be important to my plans here, because that has that -z term. And I'm going to start by combining equation 1 with equation 2. And I want to think, I have a -1z, I want to multiply that by something, and then I have a positive 2z, I potentially want to multiply that by something, and I want to get 0. Well, if I fill in a 2 here and a 1 here, that's going to work. So I want to take 2 times equation 1, and I'm going to add that to equation 2. That's how I'm going to write that. And I'm writing that down so that I remember what my plan is as I execute that plan. So my equation 1, I'm going to multiply both sides by 2. I'll have 2 times 2x plus 3y minus z equals 2 times -2. So that'll give me 4x plus 6y minus 2z equals -4. My equation 2, I'm not going to do anything to, so I'll just write that underneath this. 3x minus 5y plus 2z equals 23. And when I add those together, I get a 7x plus a 1y, and then the z terms cancel out, and that equals 19. I now have a new equation with just an x and a y, and I'm going to call that equation 4, because that's a new equation now that I have, that I'm probably going to want to refer to again later. Okay, now I combined equation 1 with equation 2. I haven't used equation 3 yet. In my next step, I'm going to need to use equation 3. I could choose equation 1 or equation 2 to use it with, but because z has this nice coefficient in equation 1, I'm going to choose equation 1. So I'm going to want the coefficient of z in the first equation. I have a -1. I'm going to want to multiply that by something. And then my -3, I'm going to want to multiply that by something as well, so that when I add them together, I get 0. Well, I mean, if I take -3 plus +3, that's going to be 0. So I can take -1 times -3 and +3 times 1. There are other choices I could have made here. For example, I could have used a positive 3 here, and a negative 1 here. But if I'd done that, I'd have to multiply both of them. If I can have one of those numbers be 1, I'm going to. So here I'm going to take negative 3 times equation 1 plus equation 2. What does that give me? I'll have negative 3 times 2x plus 3y minus z equals negative 3 times negative 2. So that'll be negative 6x minus 9y plus 3z equals 6. My equation 3, I have x plus 2y minus 3z equals negative 7. When I add those together, I have negative 5x minus 7y equals negative 1. And that's another new equation, which I'll call equation 5. Equations 4 and 5 are now a system of 2 equations in 2 variables. I now have the following system. Equation 4 and equation 5 combine to give me a system of 2 equations in 2 variables. One thing that commonly goes wrong in a problem like this is to get to this point and have all 3 variables still showing up in those 2 equations. That's not going to work. We need to have the same 2 variables in these 2 equations. If you have all 3 variables still showing up, you forgot which variable you were eliminating somewhere in the middle, which is why I wrote down in words which variable I was eliminating before I started. Okay, so now I have a system of 2 equations with 2 variables. I noticed that y has coefficient 1 in this equation. That's going to make my life a little bit easier. I'm still going to use elimination, but I think what I want to do to be able to eliminate this term is to take 7 times equation 4 plus equation 5. So I'm going to take 7 times 7x plus y, and that'll equal 7 times 19. 49x plus 7y equals 133. I'll put equation 4 underneath that. Negative 5x minus 7y equals negative 1. Add those together, and I get 44x plus 0 equals 132. Divide both sides of that by 144, and we get x is 3. Okay, we are now in possession of the value of one of the variables. Now we just go back up the ladder and get the rest of the values. So let's see. I can choose either equation 4 or equation 5 to get y. I'm going to choose equation 4 because that's going to make the math easier. So I'm going to write down that I'm going to use 4 to get y. Let's see. 7 times 3 plus y is 19. 21 plus y is 19. Y is negative 2. We now have 2 of the variables. Now we want to go back to one of our very original equations to get the value of z. I can choose any of them that I want, but it looks like 1 is going to make this easiest. Because in equation 1, I'm going to have 2 times my x is 3, plus 3 times my y is negative 2, minus z is negative 2. Oh, I've gotten very lucky here, right? Because this will be 6 minus 6 is 0. And I just have negative z is negative 2. And so z is 2. Now, I don't know about you, but I think that I could definitely make a mistake in this process. This process is not difficult, but it is time-consuming and error-prone. And therefore, after I do this, I'm going to check. I'm going to check in equation 2, where I'll plug in 3 times x minus 5 times y plus 2 times z. Does that equal 23? 9 plus 10 is 19, plus 4 is 23. Yes. And I'm going to check in 3, where I'll plug in x plus 2 times y minus 3 times z. Does it equal negative 7? Well, 3 minus 4 is negative 1. Minus 6 is negative 7. Yes. You can also just throw all of that into a calculator and make sure that it works out. So, having checked, I know now for sure that the solution is x is 3, y is negative 2, and z is 2. That is the solution to this system. Again, the work that I wrote here, with all of the notes about what I'm doing and everything, this is the actual work to solve this system. Notice it takes up most of a page, it just does. But if you work carefully, you write down carefully what you're actually doing, you'll get this right the first time, which is much better than having to try 5 or 6 times. It really is worth taking your time in solving a system like this.